Okay, this is one of the tests. It is for meant for where the slump is near to zero. You must have heard about low slump concrete, especially used for precast industries, or you must have heard about our concrete sleepers. When you are preparing, there we required near to zero slump concrete. Now the slump test, whatever we are saying, it is maybe 20 mm to 180 mm. That is the range which is generally used for normal slump test. So when you go for others, the workability lower than this, then it's difficult to manage this slump, even with the normal VB test. So now this new IS code has included this test for where you are handling concrete at very dry stage. That is zero slump concrete. As I said, it is generally used for your pre-stressed concrete sleepers. When you prepare, you must have seen or you must have in the literature. It is a very dry concrete, it's very heavy, high frequency vibrators we are using for that. And for that, because it is very high strength also, and required minimum pest to have minimum shrinkage, because this is a pre-tension sleepers. So there we need a very zero slump concrete. So how to test that when you are designing in laboratory? So that this is the modified VB test. I think more detailed when you go to the code, you'll have just I'm giving the brief about this, the concept about the test and how to manage the mix design in laboratory before going for your field production. Second is your DLC. DLC is a dry lean concrete. There is also is a zero slump concrete. Is a basically we use sub base for your pavement quality concrete. It is a range of about 100 mm to 110 mm. Or your compacted soil to put this TLC to take the levels properly and act also to transmit the load to the soil. So this concrete is also very dry concrete. It's very difficult to measure slump at design stage when you are doing it. The cement content of this particular mix is in the range of about 150 kg per cubic meter. And that is the design procedure is totally different than what we do for normal concrete mix design or construction, whatever you are using. So those concrete is a very dry concrete. It's required a special vibrator also to compact the cubes. For that, we can go through the details of MORTH, the Ministry of Surface and Transport. Specification is there for road and bridges. In that, DLC specification is also given how to design this mix. We'll discuss about this when you're designing a concrete, but it's a totally different mix. So when you are going for now, a lot of road projects are, you can see infra road projects are going on, and this is laid by the pavers. It's not laid by the manually. And then once it is laid, we'll have to compact with the rollers. And you have to achieve around 95% fill density. Whatever you are design, 100%, you have to achieve that. So such a low water content you have to use in this, and very low cement content, and able to achieve about 10 MPa strength within 10 days. So that is the specification of DLC. So how to test in fresh stage, that we will discuss in this. Then another is a new concept is coming up is a roller compacted concrete. You can use concrete itself as a dry concrete, use rollers and put it in the layers and build up a concrete. Maybe for dams or for roads, you can use this. concrete, and dry cast concrete, especially for the precast unit. So this is a VB test, which is earlier we had discussed about the normal slum concrete, maybe 80 mm, 100 mm, 150 mm slum. You test the VB test, and VB test gives you idea about how much I had to compact, vibrate the concrete, how much time I had to vibrate the concrete. That the indication gives about VB test. So this is modified this and made for low workable concrete or zero, near to zero slum concrete. Now there is a, if you see the equipment of this, there is a glass plate over the slum, and over that there is a weight. A certain weight they are given. So standard VB, you can see here, it is 2.7 kg weight is there, plus minus 0.05 kg. Now modified for DLC, this weight increased to 12 kg. Other parameters are same, the equipment is same, only the weight has changed. So when you go for DLC, you have to go for this weight. And when you roller compacted concrete, DLC or precast zero slum concrete, you can go up to 12 kg. And then roller compacted concrete, you can go up to 22.7 kg plus minus 1. So this is, you have to modify your equipment as per your application or concrete application. Whether I have to use standard concrete, maybe 80 to 150 mm slum. This is zero slum, and this is also zero slum concrete. This is recently only developed because it was getting very difficult at the site to design in laboratory for DLC. Very, very dry concrete. Now standard VB test, the time taken from frustum of cone to convert into the cylinder. That is what we are saying, a VB time. It is ranging from 5 seconds to 30 seconds. Suppose it is around 20-30 mm slum, it will take more time. If you take 100-120, it will take less time. So this indication that so much time I have to vibrate my concrete. Now once you increase your weight as per the application requirement, you can go up to 2 minutes, 120 seconds. So once you get that particular time, maybe 100 seconds, 90 seconds, or 110 seconds, subsequent batches also you can find out what is the VB time to check the consistency of the mix, whether it is coming or this. Because these are all these concrete are very sensitive to the moisture content. Any change in moisture content, even at 0.5% level, also gives different flow or different workability. So that has to be controlled at production level. So that one has to decide based on this test. See, this is the weight. This is what we are talking about. This is the weight. Now this weight is changing with the application. 2.75, 12.5 and 22.7. If you refer the IS code 1199 part 2, it has given clearly what is. So this weight is increasing, other things are remain same. And then you vibrate it and find out this frustum of cone convert into this cylinder. The time taken to convert this called VB time. And that is the basically a indication of your vibration limit for the particular specimens. Another test we are doing is basically a density of fresh concrete. Is also very, very important test when you are designing any concrete in laboratory. All our concrete mix design based on 1 cubic meter of volume. Here what is happening is all your batches, when you make a concrete, and talking about batching plant or making accurate batching in the laboratory, all ingredients you have taken by weight, including cement, water, fine aggregate, coarse aggregate, and admixture. But when you're supplying this concrete to the project site, you're not supplying by weight, you're supplying by volume. So when you design a concrete, you are designing for 1 cubic meter, and once you see the density, you have got theoretical density and you have got actual density when you produce from the concrete in the batch. So you take a cylinder of about 15 liters, 10 to 15 liters, compact manually or hand compaction as per the standard manner. You can have mechanical vibrator also, or you can have hand compaction, and then check their density of that particular mix. It should match with the theoretical density of all the batches. Once you get the cement, sand, 10 mm, 20 mm water admixture, you make a sum of that, you know, suppose it is coming 2450 kg per cubic meter. Once you produce your concrete and then you are checking your density, it should match within at least 1%. If it's not matching, there is something wrong in your mix design. Maybe calculation is wrong. Maybe the physical properties of material may not be correct, because everything is we are converting into absolute volume of that particular ingredients. Or there is a possibility that your weighing scale itself is not calibrated properly. You may be getting 10 kg, but maybe in reality it is about 9.2 kg or 9.5 kg. That all will affect basically a yield of your concrete. Yield in the sense, when I produce 100 cubic meter, it should go in the field and fill in the form. After compaction, it should fill about 100 cubic meter. If you're not able to do that, suppose I finish in 105 cubic meter, then 5 cubic meter is extra quantity. Now the debate will start, who will bear the cost of that 5 cubic meter? That one has to understand. That's why your mix design should be proper, your equipment should be proper calibrated, and the source of materials is also the same. If the source has changed, definitely there is a change in specific gravity of materials. When the specific gravity of material, their volume will change, because our whole milk design based on volume. And then we'll have a lot of issues in yield of concrete. So RMC is supplying suppose 1000 cubic meter, and you imagine you get about 2-3% variations. Then who will bear this cost? That's why yield, when you design your concrete, once you finalize the mix, you have to check your yield. In laboratory, it will come less than 0.5% because everything is you are weighing very accurately in the laboratory. So there should not be variation more than 0.5%. If it is more than that, there is definitely some error. Maybe weighing error, maybe source of materials, or maybe calculation error. That one has to understand. So this stage is very, very important. When you are working on a project, at the end of the project, after 6 months, you reconcile the concrete requirements, and as per drawing, you will find that I have to use 5,000 cubic meter, but at the end of the project, I use 6,000 cubic meter or 5,500 cubic meter. Now, who is the culprit? So, at a certain frequency, maybe every month, you have to do the reconciliation of concrete once you are buying from outside or you are producing from your own source, own batching plant. But the two teams are working. One is the executing team and one is for concrete production team. Now they blame each other. Instead of that, you come to the solution. Whenever concrete comes, you take the density and see the batch prints, see their theoretical density, and check your concrete volume. It is within 1%, you can accept. RMC people always get the advantage of reinforcement volume deduction. If they don't do the deduction for volume is, that is around 2%. So that gives the advantage to the RMC, because when you are calculating the volume of your RCC concrete, you are not deducting the volume of steel present in the concrete, because that will be reduced, then actual concrete will come. But IS provision says don't deduct the volume of steel. That goes to, because a lot of error is there, compaction, all these issues are there. So 1 or 2% variation is there. So this test is very important. Find out the yield per bag of cement. Ultimately, in whole process, you will find your cement is costly, aggregates are cheaper. To getting more yield, I can increase my aggregate content. Then, suppose I am per cubic meter, I am consuming 8 bags or 10 bags, you will find that I am actual consumer only 6 bags or 7 bags. That is one of the way people are playing with the concrete. It definitely is affecting quality also, because binder content is less, your aggregate is high. The overall quality is also good. And it has to be calibrated annually at least. You can have internal calibration, you are not necessary to go third party calibration. So this is the way we have to take a leader, compact with the proper manners in 4 layers with the square rod. Take the volume of container, and with the container you take and find out what is the density of fresh rock. So when you are taking cubes, sample for cubes, you must take density of the concrete also. So anything deviation there, you will understand there is a problem. Then you can inform to the RMC people that see this particular concrete is giving lower yield or higher yield. Both are not acceptable. Acceptable is within 1%, maximum 1.5%. That is the accuracy of your batching plant weighing system. So when you are deciding order with RMC fellow, this one of the point you have to include in their work order. The yield should not vary than 1%. That should be agree between supplier and user. That agreement should be there to understand the. Next is your air content in fresh concrete. This is not a very applicable in our area, because we are rarely use air entrant concrete. Normal concrete at least will have 1.5% air. Whatever way you are compacting, it will definitely have the air into that. But what is happening is, when you are using admixtures in concrete, there's few admixtures may entrain the air into the concrete, and that will remain in the concrete as it is. So ultimately, it will reduce your volume. This is also one of the technique. And increase my air content by 2 to 3%, adding the air entrant admixture. It gives very good workability, but also it is reduce the volume, because a lot of air is there. And these are basically a micro air within the whole body of concrete. So that one has to understand very carefully. So these are the two tests. You can go all the details in code. How it is not very. Wherever you are working for low temperature area like Himalayas or there, you need to use air in the concrete itself to take care of the freezing of your water, pour water in the concrete. So when it freezes, you are aware that ice has got more volume than water. So where that extra volume will go? So you put air in that concrete. So it will dissipate in distributed throughout the body, and it will concrete will remain intact. Otherwise, if you don't do this, your concrete will make crack because of their internal stress. That's why we should know the what is the air content in the concrete. The air content of fresh concrete. All details are given in code. I think you can go in details. We will not discuss much on this. See here. See the air content you can see. So a lot of admixtures may give the lot of air into the concrete. So that one has to understand, and accordingly you can find out the air content in the concrete and noted accordingly. Now making your cubes or a test specimen. This is the part 5 there. Earlier it was in IS 516. Now it is included in 1199. So we are given what is the slump requirement, what is the preferred method we have to use. See here, if your slump is more than 100, it is always desirable to go with tamping rod or tamping bar. Earlier this bar was not there. Since our all the specifications are aligned with the ISO, so that's why this bar is given. You can see here the square bar 25 mm plus minus length, and weight is important. There is around approximately 2 kg weight. Earlier all our specimen or whatever we are using only tamping rod 16 mm diameter and 600 mm in length with hemispherical end. So this is what we are using. But now it is included in the code, latest code 2018, that you can use also tamping bar. This is the tamping bar. You can see. Yeah, this is the square bar. So there earlier in British standard, now they are including IS also. And then we have internal vibrators. You can have needle vibrator. They are given the frequency also. You can check the frequency because we rarely check this. So whenever you are getting any vibrator, you must check what is the frequency, hertz or cycles per second, 77,200 cycles per as per IS 2505. Or you can have a vibrating table. The frequency is about 40 hertz as per IS 2512. So these are various options available to prepare a test specimen at site. Sometimes we can have vibrator also, or we can have tamping rod also. So both are acceptable. Okay. Stiff concrete is always advisable go for vibrator. You can go internal vibrator or you can go vibrating table. You can see this one video is there. Here important is if you use the scoop, don't use the towel. This is a tamping rod earlier was there. Now that, as I said, a square rod is also can be used. The mold you have to fill in 3 layers. Should be distributed properly for across the cross section of the mold. It looks like very simple exercise, and at the side generally we don't take care of this. I think we have to train a proper technician to prepare these molds, because all the test results of your specimen or your structure is depend on these cubes only. So we have to take care of how properly prepared the molds, demold and cure. Otherwise, you'll have a lot of issues and doubt about the concrete has went to the structure. And don't frequently change the person who is preparing the specimen. It should be a proper person. Otherwise, at site we have seen people are not using the same person, and every time you have to train the person. And as an engineer, it's difficult to monitor this always. So better you have a proper training to this. Level properly. Excess material we can remove. Then you have to put permanent marking there, at least some identification. You should not go only, don't write only on the pen. You have to put a proper marking, at least some number and date. And then this is also very important to cover the specimen immediately after casting. There should not be loss of moisture from the surface. Then you can write whatever other numbers you want identification on this, and you can put into the water, or you can put in the humidifying chamber like this, where you have around 95% RH in this till it is testing. This is very important, no vibration. Now this video is available on our website. Anybody wants, they can download the video, show to their technicians whenever they go for the site. So these are the one of the, we have to report you have to make on this sample report, identification, time of where, wait, what time you are prepared, because nowadays what is happening is we want also early strength, maybe 24 hours or 72 hours, 3 days. General requirement is only at 28 days. As per IS code, we are supposed to get a 28 days time, but we don't have that much time to wait. Then we do also 24 hours strength or 3 days or 7 days, and based on that correlation in the laboratory, we decide to proceed for the work. So for time is very important, because when you are testing for even for 1 day and 3 days, the time should not be more than half an hour. 24 hours plus minus half an hour, or 72 hours plus minus half an hour. And 7 days, I think 1 hour. That's why we should know, because sometimes what happens, you cast the cubes at late night and testing in the next day 10 o'clock or 12 o'clock. That is not acceptable. It should pass 24 hours plus minus half an hour, then only we have to test it. So that's why time is important. Also, temperature is also important. Because nowadays you are going in winter, so whatever cubes you cast at late night, maybe night temperature is low, the next day morning it may not set also sometimes, or is not enough set to handle the cubes. So one has to be very careful before handling this. Now compaction, what type of use? Manual compaction, vibration, internal vibration, all this they has to mention. Grade of concrete, curing method, any deviation from standard, declaration of IS code, and the person who is responsible for taking samples. That sort of format you have to prepare always. This is you have to keep a regular practice for each and every sample. Then we can keep a proper track of your sample. Identification of such a way, you have to design your number such a way that once you start one financial year, all the specimen will have serial numbers till end of that financial year. Then only you are able to track properly. Because most of the site we have seen daily they put a date and put 1 2 3 4 5 6. Next day also date and 1 2 3 4 5 6 is very difficult. We are, as a civil engineer, we are working with staff which is not that educative at site. Even your laborers or lab helpers, they are not much educated. They only the numbers. They are very careful, knows about the numbers. So we have to design such a way that there is no repetition of numbers in a particular financial year or from January to December. So then it's very easy to identify those numbers. Another practice we have to do is each and every specimen will have individual number. Because we have observed that a lot of site people are giving, suppose they cast one column, so only one column, all the numbers they give, C5, 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 all bus. That is not correct. C5 1, C5 2, 3, 4, 5, and it will come in serially. Serially from 1st of Jan or 1st of April to 31st March. Then it is very easy to identify the specimen. If you are not there, your supervisor is there, everybody is very easy to maintain that record. Otherwise, there is a lot of confusion is there. Second, you have to remember once you demold these cubes, suppose you have cast 8 specimens or 12 specimens, 1 day, 3 days, 7 and 28 days. You put those numbers and put the scheduled date. So you have to make a schedule of testing next day immediately after casting the cube, demolding the cube. Then nobody will forget this particular date what you have to test. Otherwise, at the end, maybe when the continuous concreting is there, we'll have a number of specimen and we don't know what date you have to test. So scheduling of testing is very, very important. That one has to design their own system and put it into the practice, having any doubt or any clarity on the testing part. Surface leveling, marking, capping, because if you cast the cylinders, in cube you don't need a capping. But when you cast the cylinder, the top surface is a basically troweled surface, which is not acceptable when you are testing cylinder, because cylinder we are testing only vertically. Cubes you are testing, just reverse it and get only a machine surface. So we have to leave about 3 to 4 mm gap on the cylinder specimen to do the capping later on. Maybe next day or third day we have to do the capping. Or even at the day of testing also we can do the capping. So that is very important. Next, you have initial curing, as I said earlier, or most of the people they understand curing only start after 24 hours or 18 hours. No, curing has to start immediately after casting your specimen is. Yeah. So with that person has, see, he has covered immediately. So moisture lot should not be there. And then demolding, put water curing, or we can put it at the store at 95% humidity and prepare it. So this whole process, it looks very simple, but any lacuna is there, we will have a lot of issues, and any problem with the cube at the site, everybody will disturb, right from project manager to quality engineer. All are disturbed any deviation in the cubes. Because sometimes you will find your structure is very good, but cubes are not proper, so that's given different reasons, and everybody is disturbed. So this is what important. When you dry session, you put gunny bag, and then or you can put again a plastic sheet, so it will not dries out. These are very simple tip, but is very important tip, because we have seen this. We are visiting a lot of projects. People are not taking care of this, and then they are rubbing. There's a lot of variation in the cubes. My mix is okay, everything is okay, but still why it is happening? This is
Sir,
what happening at site. Yeah, tell me.
sir, many times what we do, we don't test tube on a field. We send it to laboratory, right?
Right.
So at the time of traveling, what care we should take? Like how?
That will come. I'll come to that. I'll come to that. Yeah. So this is what the scene is there in the site, which is not acceptable. Here now you see here, few cubes are under direct sunlight. This is are under some shade. So definitely there is a variation in the strengths. So this is, we have to cover these cubes immediately like this, and that has to job you have to done immediately. So your SOP should be ready. What we have to do right from casting to till curing. So your person who is handling this has to be trained. So keep everything is ready. Once it is finished, you put the cover and then you can leave the site. Like cleaning in concrete. If you do the laboratory trials, cleaning is must. After concreting is over, mixer has to be cleaned. You cannot keep for next day. Then you have to throw. The concrete will take its own time and set, and then you have to struggling to clean it. So this is a routine has to go in the system. As a civil engineer, these are, because we rarely go to the site what people are doing. We are sitting in the laboratory or in the office and getting results from supervisor or junior engineer. But one has to go at least once in a day what is happening at site. So that gives the importance for how you are managing your concrete properly. See, this is the way we have to transport the cubes. See how they are making this arrangement. We never seen like this. We are only putting in the cement bag, dry bags, and we are sending to the site. No, that is not acceptable. Even if you see, read the specification, whenever the cubes are testing, these cubes are testing in the testing machine, it should be saturated surface dry condition. No dry cubes to be tested. So whenever you get cubes in our laboratory also, we keep 24 hours in the water and then only we test it. That is the condition. Why this condition? Because this standard is applicable throughout the country. So wherever you go, the condition should be remain same. Now drying process is depend upon ambient conditions, temperature and humidity. So I cube in Mumbai and maybe in Indore or Delhi, definitely conditions are different. The drying process is different. So it's very difficult to keep dry cubes, even moisture in the throughout the body of the cube. So they are standardized. All cubes should be tested only in SSD condition, that is surface saturated surface dry condition. So you remove from water tank, your number of cubes, you just wipe it off, keep the some gunny bag cover till it is testing. Most of the site what we have seen is People take out the cubes in early in the morning and evening while going about 4 o'clock, 5 o'clock, they start testing. By the time it is uneven drying is there, and you find there's a lot of variation in the cubes. Or they are sending to the laboratory, which has to be taken care properly. You wrap with gunny bags, then wrap with plastic sheet, and then you send to the lab. See, this case, what happens? Nothing will, your edges, everything is protected here properly. And this is only one time you have to prepare. Because when you have a laboratory, you have make two sets. So when you are delivering next, says earlier box, you can carry back again and reuse that. Because this is a wooden bag, nothing will happen to them. So this is very important. I think Nikhil, he has asked the question, and this is a very important as a civil engineer. Otherwise, what we'll do, we'll just prepare later in the our AC cabin and sell our junior the cube based on site. You don't know how they are take out the cubes, what are the numbers, nothing. No. Most of the site they put into the cement bags, wrap it, and then send it. So by the time reach the site, you will find all the corners are broken because they are taken in jeep or maybe tempo. We don't know road condition at site itself. So definitely is a 7 days cubes is there. Definitely the corners are broken, and then we are dividing the area, total area. Nobody is taking actual measurement also sometimes. But there is a requirement actually. As per the IS, whenever you are testing cubes, you must take actual measurement of the cubes. Don't assume 150 mm. There will be never 150 mm unless the cubes molds are very, very new. So you may not get correct picture of concrete strength. You must remember this. This point you have to note down. I am showing this because nothing is shown like this in your books. Books has written that all cubes should be tested only in SSD condition. You can read the specification, but we rarely read the specification.
Yes,
All the
90% of people are not following this actual
no
practice.
following because they are just following because you are not going in detail, and the
Right.
supervisor he has got earlier experience. He using
Yes,
that
sir.
experience
Yeah, generally
because
inside what happened, engineer is not looking care of this actual practices. The supervisor or the man who is allotted only is doing all this work.
but what my point is that the supervisor you can spend about half an hour in a month and train them what is actually we have to do.
Yes, sir.
That is a civil engineer's job. I am not saying he has to do the job,
Right, right, sir. Yeah.
but he has to
He
get
has to
it
train.
done at the proper system. Then what is
Right.
the use of IS code? We know everything. So what is happening is when anything goes wrong, when you go for some investigation at the site, we sit in the laboratory or in the office, engineer will give proper answers because he knows
Yes.
the procedures. But when you are going for investigation, what we have to do, go first to the site who is preparing the specimen
Yes, sir.
and how where they are stored and talk to him how he has prepared the specimen, where he has kept, what is the equipment he has used. Those things we have to find out, and you will get a lot of details. Then you come to the project manager because project manager will always give very glorious picture to you. हमारा
Yeah,
तो
technical
सिस्टम एकदम
answers.
परफेक्ट है कुछ मिस्टेक नहीं still there is a problem. So that is not the way. That's why we are what we are saying is at least in a month, one Saturday, half day you spend to your technicians, engineers, give small training, very small training. I'm not saying very big training, only how to take slump. You give around 15-20 minutes talk and tell him do and don't. That's all. How to prepare specimen, how to handle it. Small, maybe 10-15 minutes workout you can make in regional language. It is very, very helpful. Your job will be very easy. And ultimately, your knowledge will gain once you share with the other people. So, in your whenever you are deputed side, you see that training must come. It's a continuing training basically. So has to do half a day in a month. It's very easy to spend. You make a regular schedule that because a lot of developments are taking place in the construction. So sometimes you get a lot of points from the person who is actually handling concrete, and then we can correct it properly. Try to make most of the time make the SOPs, standard operating procedures, put it into regional language, and display over your laboratories, or make a one standard book. So whenever they got doubt, they just refer and come back to and do the proper procedures. This is the way we have to handle the concrete, because everybody is thinking concrete is very simple. Yeah, concrete is very simple once you understand it. Otherwise, it's very difficult. Concrete is very difficult to understand. Whenever there is something goes wrong, that one has to understand.